All right, thank you everyone for joining. Really excited to have you here. Just a quick intro. My name is Tianyi. I'm the product manager for data sharing at Databricks. And joining with me today, I have Alexei.
Hi everyone. So I'm Alexei Filanovsky, and I'm part of Oracle. Don't be surprised, you get it right. I'm part of Oracle product management team. And today we're going to talk like what Databricks is doing for data sharing, and I'll tell you what Oracle did with the data sharing.
Great. Yeah, thank you, Alexei. So just a brief overview of the agenda today. So we'll review the data sharing open protocol, what it is, how it works, and what are the design principles. And then we'll talk about how you can join the ecosystem either as a data consumer or as a data provider. And lastly, Alexei will talk about how Oracle Autonomous Database adopts data sharing. And Alexei also has some really cool demos to show. So before we dive in, actually I'd like to ask you guys for a quick favor. Could you help raise your hands if you are using Databricks? Oh, nice. Cool. Could you keep your hands raised, please? Thank you. My second half of the question is, if any of your client or any of your collaborator is not using Databricks, then put your hands down. Okay, I think we have like maybe half the hands still up and half of the hands down. Okay, thank you guys. You can put your hands down now. So we just did a quick poll. What we found is that basically among those of you who use Databricks, 50%, right, roughly 50%, have some data collaborator that is not using Databricks. So I think the conclusion is clear. In order to facilitate collaboration, data needs to flow beyond platform boundaries. But the problem is that the proprietary data platforms in the market today are not really built for such cross-platform data sharing and collaboration. Let's imagine this scenario. So say we have two collaborators. Collaborator A is a retailer, and collaborator B is one of their suppliers. And they are working on some maybe campaign planning project together. Thus, they need to share data with each other. And currently, they are using two different proprietary data platforms. So there's no easy way for them to share data with each other. There are typically two options to make it work. Option one is you can build an ETL pipeline to move data around. But the issue with this option is that it takes additional effort, right, additional engineering resources in order to build such an ETL pipeline. And also, you will have replicate data sitting in different places. And the data will become stale unless you keep refreshing it. So apparently, this option is not ideal. The second option is that if this maybe vendor one in this case provides a proprietary data sharing solution, meaning you can share data within their platform, then potentially the supplier in this case could adopt vendor one as well. But the issue with this option is that it probably takes months of coordination with their IT, security, and procurement teams to adopt a new vendor. And also, it doesn't really eliminate the need to move data around. It just happens on the supplier side instead of happening between the two parties. So as you can see, both options are complex and expensive, and they don't really scale with the growth of your business. Just imagine if you have to repeat this process for many of your partners. It's a nightmare. So that's why oftentimes data still remains in silos and doesn't generate the value that it should have. That's why Databricks and the Linux Foundation, we introduced data sharing. It's the industry's first open protocol for secure data sharing. Under the hood, it's just a simple REST API that defines a secure real-time exchange mechanism for large volumes of data. And for the first time, it enables a platform-agnostic approach for data sharing. So let's take a look at what are the design principles of data sharing. These are adopted from day one and still true today. First is, we wanted to allow users to share data live without having to copy or replicating it. So that way, you can lower your cost of operation. And secondly, we wanted to support the widest range of clients. So that's why we defined the protocol using some of the most commonly used technologies, such as REST API, Parquet, Delta storage formats, etc. So it's really easy to build a connector using any programming language and ultimately reduces the friction for data consumers to query the data. And third is we wanted to enable the user to easily secure, govern, and audit shared data in one place. And fourth is we wanted to just leverage some of the most scalable and reliable cloud object storage in the market, such as AWS S3, Azure ADLS, Google GCS, etc. So anyone can share terabyte scales of data easily. So let's take a look at how it actually works. There are two parties involved here. One is the data provider, and another is the data consumer. So on the provider side, what they can do is to set up this data sharing server and connect to their existing data lake on any cloud. And then they can define some access permissions on the server, which basically specifies which consumer can access what data sets. And then they can generate a credential for each of their consumers, which they can use to authenticate to the server. Then on the consumer side, they can just grab any of the data sharing client, including the open source ones like Pandas, Spark, or the commercial ones like Power BI, Tableau, or even Excel. And they can just use the credential to authenticate to the server. And when the server receives the request, it will first check the permissions on the credential. And if it passes the authorization checks, then it will generate and returns short-lived tokens back to the consumer, which directly references to the files in the cloud object storage. So that way, the consumer can securely and directly read the data from those cloud object storage. So as a consumer, it's really easy to query shared data. Here, I'm just using the Python library as an example. It's really as easy as 4 steps. First step is you install the data sharing library, import it to your codes. And then you can create a client using the credential that the provider generates for you. And third is you can call this list all tables API to browse through what are the data, what are the tables being shared with me. And lastly, you can load any table, either as a Pandas data frame or Spark data frame, depending on what compute platform that you're using. So that way, you can maybe join it with your other data or do whatever you want. So it's anywhere you can run Python, you can query data share data. I'm also excited to share that Databricks and Tableau have recently released a new data sharing Tableau connector. So with this connector, data users, data analysts on Tableau can easily tap into data shared with them via this data sharing protocol. With this connector, it will accelerate data visualization and data-driven decisions for those who use Tableau. And the connector is already generally available for download from the Tableau Exchange. At Databricks, we integrate data sharing natively with the Databricks Data Intelligence Platform. And it comes with a bunch of benefits out of the box. First is, with the help of Unity Catalog, any user can centrally manage, govern, audit, and track usage of the shared data in a single pane of glass. And then you can collaborate on more than just data. For example, you can share unstructured data like files, images, or codes, notebooks, or even AI models. So it's really easy to kick off any AI or BI workloads with data sharing. And you also have easy access to a broadest ecosystem of connectors and data. You can share data with those open source clients that we just talked about, and also commercial clients. But also, as a data consumer, you can get data from maybe third-party data from vendors on our marketplace. Or you can also bidirectionally exchange data with some other SaaS platforms that support data sharing. Over the last few years, we've seen tremendous growth in our data sharing open ecosystem. It's been widely adopted by a lot of the industry-leading partners, as well as Databricks customers. It benefits everyone in this ecosystem. As a consumer, you can easily get this wide range of data without limitation on platform. And as a provider, you can maximize your reach to Databricks customers, as well as anyone else who's using data sharing. So together with these partners, we believe the future of sharing is open. S&P Global, for example, is one of our new strategic partners. They are making the Capital IQ company and market data available in the data sharing network. And they are expanding to other data sets as well. So with data sharing, they are making their data more seamlessly accessible and available to their clients in the financial industry. And next, I'd like to talk a little bit more about, as a data provider, how you can benefit from data sharing and reach all your clients wherever they are. First is, you can definitely use the out-of-box Databricks data sharing service, which comes with the benefits we just talked about, and it's also used by most of the providers. Or if you are like a DIY type of person, then you can host and manage your own data sharing server from open source. That's actually what Oracle does, and Alexei will talk about it in a minute. But another interesting pattern that we've seen getting a lot of traction recently is to build your own data sharing service on top of Databricks data sharing. So it's like a built-on pattern. Here I will talk about roughly how it can work. So you can still leverage the Databricks data sharing service as the backend. So it will help you handle data governance as well as credential vending. So it will help you generate short-lived tokens for your customers. And then you can put your own web application or API gateway in front of the Databricks data sharing server. And it still speaks this data sharing protocol with your customers. So that way, you can get both the data governance benefit as well as the rich ecosystem benefit from using Databricks data sharing. And the common use case is that you probably have a product that your users request and access data. And you wanted to control the UI and you want to control the API that your users interact with. So that's why you can do this on top of Databricks data sharing. And regardless of which tool that your users are using, you can fulfill their requests. Atlassian, for example, is one of our kind of built-on partners. They have a product called Atlassian Analytics, which provides flexible and a simple way for their user to visualize and analyze data from other Atlassian products, such as Jira, Confluence, etc. So with the help of Databricks data sharing, they can now easily empower their users to connect to the data using their tools of choice. And it's actually being widely adopted by many of our partners and customers. You will hear more from Atlassian about their successful story in a session later today. And another great story is from NASDAQ. They have a product called NASDAQ Data Link, which is like a platform that provides access to hundreds of market data sets. They are also using Databricks data sharing under the hood to fulfill requests from their customers, such as analysts from investment banks or hedge funds. So they will join a session on Thursday to talk about their story. And lastly, I know you must be interested in how to host and manage your own data sharing server, and maybe look at some demos that Alexei have. So Alexei, pass it to you.
Happy to help here. Thank you. So hi, Eran. So you may be surprised why Oracle's here, but no worry. So hopefully I will answer this in about 10 minutes. And let's start with a quiz. Who knows what Oracle database is? Raise your hands up. OK, quite a few people. Who knows what Exadata is? OK. Who heard something about Autonomous Database? Oracle Autonomous Database? Few people. OK. Basically, like most of you know what Oracle database is. Then we put it on something we call like hardware uplines. So it's called Exadata. It's hardware, software built to work together. Then we host it into the Oracle cloud infrastructure. Yes, Oracle is a cloud provider. And sprinkle on top of this with our 20, 30 years experience and tune this database automatically for you. What do you get as a customer? So with Autonomous Database, you don't have to hustle with many things. So you don't have to do like patching. You don't have to do backups, etc. We take all these burdens out. So this is a very busy slide. It's very hard to read, but basically the gist is that you don't have to do the many things you don't like with an Oracle database. So it's really hard to manage. So with autonomous database, we hope to eliminate this hassle. Also, Oracle Autonomous Database is one of the innovative cloud database into the Oracle portfolio, and all latest and greatest features we first built into the Autonomous Database. And one of the example, it's data sharing. The good news, when you provision this service, so you don't have to install or manage or do anything else. So like Oracle Autonomous Database is ready to be your data sharing provider or data sharing consumer. So it's available out of the box. And basically, it completes our data sharing portfolio. Of course, if Oracle wants to share across like database ecosystem, we have like special protocols, special path called Cloud Links. But we are open to others. So, and we have like customers who run Databricks and Oracle, and they used to suffer from the silos. So data being siloed, like one data set in Databricks, and there are very valid reasons to use Databricks, and there are other data sets into the Oracle database, and there are very valid reasons to use Oracle database. And there is a very clear problem that data are siloed. So like part of data in Databricks, part in Oracle. With support of data sharing protocol, we hope to help our customers to break down those silos, and customer can easily exchange data sets without like really copying data over. So you just query data in place. But probably you want to see something, and you want to see something in action. And let me show you a demo. So imagine for a second I work for a company called MovieStream. This company sells online content. So I sell like movies, TV shows, etc. And by the way, forgot to mention, I'm Mike. I'm data analyst. I know something about IT, but I don't have strong background. My primary focus is Oracle Autonomous Database. Our company is rapidly growing, and we have like lots of IT solutions in our disposal, like big data platform built on Databricks, like data warehouse built on Oracle, but people like Power BI. It's a very decent tool, and our analysts heavily using it. And data scientist, of course, is up to Python. So with that said, one day, instead of morning coffee, I got an annoying email. Our business is losing customers. What I need to do, I need to ask my analyst and data science team to help me find out why, but they need data. I know that some data sets are in Databricks, and Databricks folks at the past made some research, and they tried to predict customers who's willing to churn, but data is siloed in Databricks. I have some transactions into my Oracle database, and what I need to do, I need combined datasets from those two entities and provide it for Power BI and Python. Okay, first step, I pick up a phone and call my Databricks folks and say, hey guys, can you create a share for me? That's not a problem. Thank you. So you can see Databricks. It has nothing to do with Oracle, so it's Databricks. It's a very straightforward UI. Kudos to you guys, so being so clear. I just click create a share. I browse and pick our data sets I would like to share. So, and then I have to create a recipient. It's not Databricks recipient. I'd have to just give it a name, and that's it. So share is created. But I need to authenticate somehow. I cannot just come and say, hey, give me a data. I need to provide some token, right? I need to go somewhere. I need to know endpoint. And all this information, all this connection information hosted into the credential file. Like basically Databricks, Slack me or email or write on piece of paper this URL. I follow this URL. I download data sharing config file. This is a key from the kingdom. Next, I go to Autonomous Database. Okay, I have credential file. I have file that gives me access to Databricks data sharing. What I'm gonna do next, I'm going to my Oracle Autonomous Database, and I will provide a share. So, I will consume share. I will be consumer in this case. And what I need to do, I need to subscribe to the data sharing provider. The JSON file I downloaded a couple seconds ago, I export into my wizard. So give it a name, and I subscribe to the Databricks provider. I'm not copying data over. I just go to the endpoint and say, hey, this is my credentials. Do you have any objects I can consume? And then I can see objects that are available for me for consumption. So by consumption, I don't mean copying or loading data in Oracle. I create something we call external table. It's just a set of metadata over real data that's hosted in Databricks. So data remains in Databricks. Oracle just use external table to query this data. All right, great. Databricks was able to create data share for me. I was able to consume it. What I want to do next, I want to enrich this data set with Oracle internal data. I would like to maybe build some join and then create data share over this view. So I create a view. It consists of few tables, like one tables belong to Databricks, one tables belong to the Oracle database. And I created this view, and I need to create data sharing over this view. So of course we support tables, but we use kind of more interesting example. I pick up a type of the share. It's a data sharing. And I can browse objects available to share. I pick up a view, so it can be like multiple views or multiple tables. And I create a recipient. And then we automatically generate email. And this email will have a URL to their config file, to the data sharing config file. Sounds familiar, isn't it? So we follow Databricks model. So Databricks, whenever Databricks wants to share data outside of Databricks ecosystem, you have to go and download this credential file, data sharing config file. We do the same. It's key from the kingdom. When customer have these keys, like he or she able to consume it. But let me show it. So now Python and Power BI are ready to consume this data set. Okay, let me start with the Python. This is a straightforward code that basically read a configuration file, and then it creates some objects and print name of the schema, print name of the share. Within share we have schema, table, and then it print first 10 rows of this code. So it's just a Python code. I intentionally didn't use any ID to highlight that it's a vanilla Python code. So, and basically I was able to query data using Python code. Next example, it's a Power BI. So I go to the Power BI and I specify data source. It can be like Oracle, it can be MySQL, it can be Teradata, or it can be something new, like data sharing. It's type of data source. So in order to access it, I need to know the endpoint. I need to know whom I have to talk with to be able to consume data. I go to my config file, I fetch my endpoint URL, and then I connect. Well, going to this endpoint, I call and say, hey, can you show me all available shares and all available schemas and all available tables or views? I pick up one table, and I'm ready to start analyzing this. So, and I want to highlight that there is no any extra limitation, or not any. There is no anything you cannot do with the data sharing in comparison with the traditional, let's say, data source. So you can connect to MySQL or Oracle or any other database and do the same research. So probably here I would answer one question. Many of you are sitting and think, hey, can Power BI just connect to Oracle? Why do we need this extra step? This is a good question. Thanks for my virtual attendee who asks it. So this is a good question, but basically a key here is that it's a consumer pays model. So consumer, as you may remember from Tino's slides, consumer goes directly to the data layer. So it bypasses their actual processing, and it allows you to build this data sharing platform. So when you bypass like Oracle database instance, we just act as a data server. We authorize you to read, and then consumer reads these Parquet files. And it is a true consumer pays model. All right, let me just highlight and what I would like you to take away out of my part of presentation, just two pieces. Oracle can be data sharing consumer. If you have Databricks, and Databricks, of course, like are supporting and pioneering and doing great with the data sharing, and Databricks is your data sharing provider, Oracle can be consumer. So Oracle easily can consume data from Databricks and other data sharing provider. If you want Oracle Autonomous Database act as a data provider, we also can do this. We bake in and embedded this open source protocol right into the core database. And like core database can act as a data sharing provider. All right.
Hello. All right. So I think that wraps our talks. And I also wanted to do like a quick plug of some future talks that is related to the data sharing ecosystem. For example, we have a couple of talks from our data partners like AccuWeather, S&P. They will talk about kind of their experience, sharing data to Databricks, not Databricks, right? Data sharing recipients. And then we also have some other SaaS and technology partners. For example, Amperity, they are actually also adopting the open source data sharing, very similar to what Oracle does. So they are also like a server as well as a client of data sharing. And we also have some other built-on partners that will talk about their experience building data sharing service using data sharing. So yeah, feel free to go to those sessions if you would like to learn more.